Well, I think it's time to start. I will begin with a word of prayer. Ahem. Hem. Hem. I said hem. Heavenly Father, we thank you for this day. I thank you for these students. Just ask you bless this time we have to study your creation. Help us to understand math together and to use this time, Lord, for your glory. In your name I pray, Lord Jesus. Amen. That reminds me, I need to bring a whistle for Math 115 next week. I could not get them to shut up at the start of class this week. And I'm not one of those people that can do that whole like loud whistling thing. Like it's not one of my skills. So you guys excited about the weekend?
Yes. Are you?
I don't know. A little bit crass.
What?
A little bit crass.
You should come to the football game.
Yeah, the week. I'm looking forward to the weekend. It should be. It should be good. What time is it? This is the 3:15, right? Yeah. All right.
I support from a distance.
You guys better top hat pretty soon. My computer's almost out of batteries. I'll be shutting it down here pretty soon. So 4201. 4201. All right, so any questions? Yeah? Questions? No?
I do.
You do.
I was having trouble on number 12 homework because we didn't really do one that's simple looking. I didn't really know what to do.
Yeah. There's a few problems that we haven't quite done the same pattern of. Very good. Example 1. Let's work with 12 over x plus 6 less than or equal to 2. This is like number 12.
Yeah, we did this one, yeah.
Oh, we did this one?
No, on the homework I did it.
Oh, okay.
Sorry.
Did I do it in here? I mean,
No.
okay. I have trouble remembering. Yeah.
The answer is 5.
The answer is 5.
The answer is not.
All right, so first of all, if this was an equation, how would you solve it?
Percentage equal to 0, I should say.
So if this was an equation, I would just multiply by x plus 6.
Oh, that's what you
It would give me this. I would subtract 12 from both sides. I would get 0 equals to 2x. I would give me x equals to 0. And I'd be like, yay, done. However, this is not an equation. And for that reason, I would ask you, why don't we just multiply by x plus 6? Like, why is that actually kind of like not a good idea?
These are greater than 2.
What? Greater than what? Greater than what? Less than 2? I mean, what's the problem with just multiplying by x plus 6? It's a what? It's an inequality, right? But what makes it dangerous? I mean, we can multiply inequalities by numbers, right? But then what's the trouble? Is it positive? Or is it negative, right? Is x plus 6 positive or negative?
Negative.
It could be positive, it could be negative. Like if x is minus 8, it's negative. If x is 0, it's positive, right? So if you multiply by x plus 6, you're obliged to take and follow two different logical paths. You have to break up into two cases. Either x plus 6 is less than 0, or x plus 6 is greater than 0, and then you have to pursue those logical possibilities separately. That's a pain, right? Much easier is to reforge this problem as one of the ones we already know how to do. And to do that, I need to make it a fraction less than 0. Okay? So that's easy enough. All we do is subtract 12 from both sides. Excuse me, 2 from both sides. Right? And then I've left myself some space because I want to make a single fraction. I want to make a common denominator there. So what I'm going to do is I'm going to multiply by 1. And that 1 is going to be x plus 6 over x plus 6. So I'm just making a common fraction. So I've got 12 minus 2 times parentheses x plus 6, all divided by x plus 6, less than or equal to 0. And just a little bit more, I need to clean it up, you know. So let's see here. This is what? Oh, check that out. So 2 times 6, that gives me minus 12. So we're just left with minus 2x over x plus 6 after we clean up the numerator there. Okay, now this problem you probably wouldn't have had trouble with, right? Because this is one like the ones we've already done in class, right? I need to do what? Now we're in our 4-step process. We have to identify the critical numbers, draw the number line, test points in each case, write down the answer. So what are the critical numbers here for this one? What was that? I heard a 0 and a minus 6. Very good. Now I make my number line.
How did you get 0 for the critical number?
Because x is on the top. That's 0. So how do I get a critical number? It's either what makes the fraction 0 or undefined. So since there's an x up here, if you plug in 0, you get 0. It's because of the x.
So every time you look at x in the numerator, you all look 0 as your critical number.
Yeah. As long as it's just an x by its lonesome, you know? Like if you were to... if I was to look at this one, you know, if I was to look at that problem, my critical numbers would be what? -4 and 3, right? Now, see, you said if there's an x in the numerator, that's going to give us 0 critical number. So it depends on what you mean by that. I mean, there's an x in this numerator.
Well, like if it's connected. Okay, I got it.
You got me. So, you know, I'm being annoying, right? But see, this is the trouble. Sometimes I agree to something a student says, and they mean something different than what I need them to mean, you know? So as long as we're on the same page, like x has to be a factor, right? It has to be, you can factor it out. So, very good question. -6 and 0, right? So then what? Plug in a point? Which one should? A lot of times I've plugged in 0, right? 0 is one of our critical points. We can't plug in 0 here, right? Why do you guys keep picking -1? Every class picks -1. Where is that coming from? Why do you guys pick -1? You're the third section that has suggested -1 on this example. What is up with that?
Hey, put 5 in there.
Put 5?
5.
Such enthusiasm, I can't deny it. I'll put a 5 in there.
Yes, God.
-2x over. It really doesn't matter, just as long as we pick something and get started. So put in 5. -2 times 5 over 5 plus 6. -10 over 11. That's minuses, right? Now, if we had plugged in -1, what would have happened? We would have gotten positive, right? So if we plugged in you guys test point of -1, we get a plus here. Now, do we need to plug in test points other than, I mean, once we get 1, we don't really need to plug in test points. We could use the sign flip theorem, right? 0 corresponds to x. It is first power, right? Which means we're going to change from minus to plus as we go across the critical number. Here, x plus 6, first power, means we're going to change from plus to minus as we go across the critical number. So we got minuses over here. Was there a question? Yeah? There wasn't a question? Oh, okay.
I'm with you. I'm saying I'm with you. All the way.
I got you. So you have, okay, great. Now what?
I got
We'd like to write down the solution, right? Solution set. Everyone top-hatted? Anybody? Okay. So, all right, so what are we doing? We're solving less than or equal to 0, right? So what are we looking for on the number line? We're looking for places where it's negative, right? So that's here or there. So for the left one, we do minus infinity. And I'm going to have to erase this. It's in my way. Sorry.
Wait, so how do we know?
You gotta put the long comment, you gotta put the bracket in there.
And minus 6. And then 0 to infinity. My question is, are we including minus 6? Why not? Why are we not including minus 6? It makes it 0. It makes what 0? The denominator, right? We have division by 0 at minus 6. That is why we must exclude it.
But it's less than or equal to, so couldn't it be included?
Well, if you have, but I mean, it's in the denominator, so it's not equal to 0. It's undefined. If I plug in minus 6, I get minus 2 times minus 6 over minus 6 plus 6. This is not equal to 0. This is equal to 12 over 0, which is undefined. So that's why we have to exclude minus 6. 0, on the other hand, if we plug in 0, what do we get? We get 0 over 6, which makes it 0, which is one of the things we're looking for, so include it. There you go.
So how do we know we're looking for negatives on the number line instead of positives?
It depends on the problem. This problem is less than or equal to 0. That's why I was looking for negatives.
So what was less than or equal to? Okay, never mind.
Up here,
If it's greater than, it's going to be positive.
right, this one here, if we put in minus 4 and we put in 3, you can plug 0 in. What happens when you plug 0 into this expression? So if we plug in 0 here, then that gives us 0, it gives us 4 over minus 3, which is negative. All right. And I actually like to do different colors for the different signs, but I don't always do that in here, but I like to. Anyway, so this one flips pluses to minuses on both minus to plus rather, both places, because both of the factors are linear, order 1. So back to your question, how do I know to look for pluses or minuses? It depends on the kind of inequality you're looking at. This one here was greater than or equal to 0, right? So I'm looking for pluses. And what's my solution? Looks like minus infinity. How did I have? Oh, it's because I had that minus. Okay, never mind. It's weirded me out. The pattern is weirded me out. I'll get over it. Minus 4, 3, infinity. Now this time, do I want to include or do I want to exclude minus 4? Include. Why? Because it's a positive? It's 0. When you plug in minus 4, it's 0. It's not plus or minus. It's
not in the denominator.
It's not in the denominator. That's better. So it's in the numerator, right? If we plug in minus 4 here, we get 0 over like minus 7, which is 0. 0 over a number is still 0. It's fine. If we have 0 in the numerator, no problem. Right. So this exactly. Putting in minus 4 makes it equal to 0. This is a case we're interested in for this question. How about plugging in 3? The denominator is 0, which means we must exclude it. So there you go.
And that's because we were looking for the positives.
Because we were looking, exactly, we're solving greater than or equal to 0.
All
Yeah.
right, I got you.
I don't know what the little thing does, come a long comment.
All right, there's another kind of example we haven't done yet. Let me do it, all right? I mean, we've done something very similar to it, but not quite this one. It's like number 14. So suppose you're up against x plus 4 times 2x plus 2 times 3x minus 9 less than or equal to 0.
You just said it over here.
Yeah. So this is problem number 14. It corresponds to exercises 87 through 90 in your homework, in your book. You're supposed to use the zero factor property. Zero factor property is just like their terminology for the four-step process I was talking about. Mostly. What are my critical numbers? -4, -2, 9 is incorrect. Why is it incorrect? So what we got to do, let me, it's all good. Let's work it out. So what we're trying to do is solve x plus 4 equal to 0, solve 2x plus 2 equal to 0, solve 3x minus 9 equal to 0, right? That will tell us what the critical numbers are. Now we haven't needed to write that down in previous problems. Why? It was just, you could just see it, right? You don't need to write the equation x plus 4 equal to 0 down to see x minus 4 is your solution, right? But when there's factors like the 2 here and the 3 here, maybe it's a good idea to work it out, right? -4, yeah. X equals -1, yeah. X equals to 3, right? So these are the critical numbers. Because those are the numbers that if we plug them into the factors, we get 0, right? That's what makes it a critical number. Okay, then what? Number line?
Yeah. -4.
-4 comes first. Are you sure about that?
Oh, yes.
Okay, good. -1 comes next.
No, I think 3 does.
No, it says one, yeah.
Three.
Still right.
3. I'm just trying to make you doubt yourself.
And got me
Let's see here. X plus 2. And I'm just writing it here to remind myself what I'm looking at. All right. So what do we want?
0.
You want 0? All right. Where is that?
That's right there. You're on the, yeah, you're
Right there. Plug in 0, we get what? 4 times 2 times -9, which is negative, right? Now what? Yeah, now we can use sign flip theorem. These are all linear, which means we're going to change from plus to minus at each critical number. So minus changes to plus. And then here, plus changes to minus. Now we're solving less than or equal to 0. What's the solution then? All the negatives. So yeah, all the negatives is a good answer. So we want minus infinity to -4. All right. Now, what about including and excluding here? Do I want to include -4? Yep. The reason for that is equals 0 is part of the story here. That makes the expression 0. So we certainly want to include -4. Same for -1, and the same for 3. And you should check and make sure that's, do we have all of the zeros? There are 3 zeros for this expression, right? And we have all 3 of them here, -4, -1, and 3. So it's good.
All right, we done, right?
Well, with this example. We just got here. That umbilicus is going to get me one of these days. All right.
Are you growing out the beard?
Sure, why not? Look like Wolverine, I think. Not really. Let's see here. So you guys have any questions about a particular one? Nope. All right, well, let me forge ahead here. Oh, did you panned the camera over here, right? Okay, thank you. All right, let me find, let's see here, we did, yeah, I should do another one of these. X plus, this is like number 13, x plus 2 over x minus 7 less than or equal to 1. So what do we want to do? It's kind of the same problem as example 1, right? What do we want to do to it? We want to move the 1 over. Ooh, I haven't done that one yet. Huh. All right, so I just noticed there's one that I haven't done in any of the sections yet. Oh no. Well, you guys should be able to use the techniques we've done to solve some problems which are similar, but a little bit different. But okay, so that, now we got less than 0. We need to take that 1 and turn it into something we can add to. So basically, I kind of just changed this 1 to what? X minus 7 over x minus 7, like that. And then this gives us x plus 2 minus, parentheses are your friend, x minus 7 divided by x minus 7 less than or equal to 0. Notice how that works out. The x's cancel this time, right? And you're left with what, 9 over x minus 7. This one's actually even simpler than the example 1. And so what's the critical number or numbers? Yeah, critical number is just 7. Yep. And so we draw a number line, put my 7 down, and you know, just plug some points in if you want. -1. 0. Fine, 0. What happens when you plug in 0? 9 over minus 7, which is what? Negative. So it's negative over here. And where is it positive? On the other side, right? I think more responsible choices would have been plugging in 8 or 6. That makes it easy. 8 and 6 are nice points to plug in here, because then you've got like 8 minus 7 is 1, or 6 minus 7 is -1. And it doesn't matter. Plug in whatever points you want. It's minuses and pluses, right? What are the solutions set here? Solution set. You said minus, where the minuses are? So we do minus infinity to 7. Do we include or exclude 7? We must exclude it because plugging in 7 gives us division by 0, which is not allowed. In fact, this expression is never 0, right? If you tried to solve 9 over x minus 7 equals to 0, you'd never find anything. It's never 0. So the only way to have a fraction equal to 0 is if the numerator can be 0.
How are we going to put the negatives on the left side of the 7 when they're minus 7, right?
We plugged in a point. So I was told to plug in 0. So I plugged in 0. We plugged in 0. We got 9 over minus 7, which is negative. Yeah. Any questions? All right, let's. I just noticed one I haven't solved yet. This is exciting. I didn't even notice that this one's actually kind of different. This is just for you guys. All right, so here we go. Example 5. 6 over x minus 2,
Gotcha.
absolute value,
Oh.
equals to 11. That's not what you paid for. They didn't give me any of that money, so I can't give it back. Let's see here. So, what we do?
So you go take 11, you know what I'm saying, flip it to the other side. So you got 6 over 2x, you know what I'm saying, minus 11, you know what I'm saying, you got to break it down.
Break it down.
I don't know if I'm saying that's correct, but I'm just going to go on my first instinct. So you do like 6 over 8.
Well, I mean, let's just think. Exactly. So in order for this to have a solution, we either need that 6 over x minus 2, it's that either be equal to plus or minus 11, right? Now, you could use the plus minus notation here, or you could divide and conquer, right? What do you guys want, plus minus or divide and conquer? Divide and conquer it is.
What's that? See, that's what we're talking about.
So we multiply both of these equations by x minus 2. What happens?
11 times 6 and x plus x minus 2.
Now I distribute the 11. We get 6 equals to 11x minus 22, or 6 equals to minus 11x plus 22. Solve for x. Yeah, so here we get 11x equals to 28. Over here I get 11x equals to 16, thank you. And so x equal to 28 over 11, or x equal to 16 over 11. Two solutions. There you go. I sense you want me to work another one. Is correct? All right. Let's work something like number 22 in the homework. You guys, I need to get an extender for that, huh? No, so here. You guys seen the Rings of Power?
I heard it's mid.
Rings of Power, like the new Lord of the Rings thing on Amazon. It's so bad. It's wonderful to watch. It's so horrible. You can watch it, and then you can watch all the people criticizing it. That's the joyful thing about it. It's not that it's good. Yeah. I mean, they spent like what, millions upon hundreds of millions of dollars producing this thing. It's beautiful. It's, it's nice to look at. But it's bad. It's pretty bad. Like I have zero hope of my wife like watching it more than about like 3 minutes. Like she would get bored of it so fast. Example 6. But I mean, if you like watching something so that you can understand other people making fun of it, then it makes sense. Kind of like She-Hulk, right? Okay. So, not that I've seen that. I just don't care. I can't express to you how much I don't care about it. Anyway, so divide by 5 is the way to go here, right? Yeah. So if we divide by 5, then we have something that we kind of know how to deal with. If I divide by 5, we get x minus 4 is greater than 10 over 5, which is what? 2, right? At this point, I must remind you, we have two things we need to fall back on. Absolute value of A is less than B if and only if minus b is less than a is less than b. Absolute value of a greater than b if and only if a is less than minus b or a is greater than b. These are our fallback theorems, truths, fun facts, what do you call them? And here, of course, we're assuming that b is positive. All right, be positive. There you go. Turn that frown the other way. Let's see here. So what do I do? It's a greater than absolute value problem, right? So I'm forced to use this theorem right here. With b what?
So x minus 4 is
Mm-hmm.
greater than 2.
Well, I mean, yes, but I insist on us writing the less than one first. I mean, less than minus 2, and then what you're telling me. Or
Or x minus 4 is
greater than 2, right? These are disjoint cases. We have to treat them separately, right? And so add 4, what do we get? 2. Over here, add 4. X greater than 6. So either we have x as an element of minus infinity to 2, not included, or we have x as an element of 6 to infinity. Which means our solution set, when you put these two things together, is minus infinity to 2 union 6 to infinity. What about what?
One on top of the 4, x minus 4. No, it's about 5 up. Yeah, what that?
We divided by 5. Divide both sides by 5.
Oh, I thought it was 2 different problems.
No. Divide this by 5. Divide this by 5. And that gets you here. It's okay. I should have written it down. Let's see here. So example 7. Yeah, no. It's same problem. Same problem. Let's see here. How about this one? What if we are going to solve example 7. Absolute value of 7y minus 2 greater than or equal to minus 12. First of all, does it actually fit the template, either of the boxed equations, either of the boxed equivalences? It doesn't, right? Because in fact, what I'd like to be b here is not positive, right? This is a negative number. So it's not the same logical case as what's at the top of the board. It's actually easier. Yeah? What can you say about, let's see if I can write this. Let me write a sentence which is true under it. Minus 12 is less than 0, right? We all agree? Property of absolute value, less than or equal to 0. Gives me the absolute value is greater than or equal to 0, which here gives me this statement. I mean, this is a property of absolute value. The absolute value of A is greater than or equal to 0. This is just a truth about the fact about the absolute value function, right? So I can write down minus 12 is less than this, is less than that. It doesn't matter what y is. Y can be anything, right? So what's the solution set? All real numbers, right? Solution set here. Another example in a similar vein, but this one doesn't have as happy an ending. Well, I don't know. You decide whether or not it's a happy ending. 7y minus 2 less than minus 3. Yep. Then there's no solution, right? Because it's impossible for the absolute value to be negative. This is absurd. The absolute value of 7y minus 2 is greater than or equal to 0, right? So it can't be greater than or equal to 0 and less than minus 3. So therefore, no solutions. In other words, the solution set is what? It is, yeah, the empty set, or sometimes you do it like this. Curly bracket, nothing in the middle.
On the test, we write no solution.
Yeah, that'll work.
Okay.
I mean, if I say, it depends on the wording. You know, if I asked to write the solution set, then I would, you know, it would be good to say no solution, so solution set is empty set. I mean, am I going to take a point off? It really depends on the problem and how much of the problem was writing the answer in set notation versus not. It's not the end. It depends. I mean, if I just say solve the inequality, I've left myself open for a variety of answers, right? If I say solve an inequality, one could reasonably say that the solution is something like, you know, box this and box that. But I won't do that. If I have this, I'm going to say find the solution set in interval notation, right? And then I'll probably say, or state the solution's the empty set if there's no solution.
Will you do that?
Could I do that? I mean, if you'd like.
Will.
Will? I don't know. I haven't written the test yet. Hey, when's our quiz? Next Wednesday. Ah, yes. What are you allowed on the quiz? A sheet of paper. What can you put on the paper? Anything you want. Very good. All right, you guys are. How about solutions to examples? Yes, you can put solutions to examples. That's all right. Psalms, Proverbs, pictures of your beloved. It's all good.
So can I put the answer to every question?
If you could put the answer to every question, that would mean that you're a psychic, because you could read my mind.
If we did have the answers to every question on there, and it was just by chance, would you count off?
I would. You have to show your work. Let's see here.
You have to show your work.
What if we had
Well,
every?
I mean, we don't have to. I mean, we can. There are two paths we can go down here. Like, there's also the just write the answers down, don't show your work. But that path also has this other thing attached to it, which is no partial credit. Easier for me. I just grade answers.
Show our work.
I think we should show work. Yes.
Wait, so if we show all the work correctly, and then forget to write a 7, we'll still get a lot of credit?
If you show all your work correctly and then forget to write a 7.
It's like it's a big answer, and you forget to put the 7 in there.
I mean, everything is correct, and you just write the answer down a little bit wrong.
Yeah, would you give some credit?
I would give most of the credit in that case. Yeah.
You wouldn't give most?
I would give most, if not all of the credit. Yeah.
Oh,
Yes.
The thought process behind it.
I am harmless.
So you want to know what
It's the,
I'm not going to be good to show my work. I'm good to find the answer. I don't know how I've done this.
on the other hand, if you show wrong work and you have the right answer, you can also lose points. So there's that. There's a problem in here I was going to work for you guys. Now you've distracted me with all your interesting questions. Where was that thing? Absolute value of, oh, that's not the one I want. That one's too easy. We did that one last time.
You want some really hard one.
I'm working on it.
pick one that will make us know the answer.
Yeah, like just, you gotta be like, not on the paper, like something freestyle a hard one.
Freestyle a hard one.
Yeah.
Physics problem. It's gonna end up being like.
Who's geometry?
What? Yeah, this is very annoying. I cannot find that problem for the life of me. Just a second, guys.
Yeah, we got 3 minutes left.
3 minutes? What are you talking about?
It's 4 hours.
It is not. Nice try. let's see here, 3x. And besides, this class ends at 4:30. 3x plus a half minus 5 less than 5. Here's the problem. This is the one I wanted to do. Woohoo! It's number 26. This is our next to last problem. We still have time for 2. What's that? Subtract 5. Right idea, but instead of subtract, we want to add 5. See, because yeah, add 5. So add 5 to both sides. You're all good. So that gives us absolute value of 3x plus a half less than 10. At this point, we are in the right pattern to use our, theorem about absolute value. And so what I'm going to do is I'm just going to, I call this unwrapping the inequality. So instead of having absolute value, we can unwrap it as minus 10. Oh, come on. Less than, you're dead to me. All right.
Less than 0.
Minus 10 less than 3x plus 1/2 less than 10. Then what should we do? As we have a deep-seated hatred of fractions, right? So we want to multiply this by 2. Multiply by 2, what happens? Negative 20 less than 2 times 3 is what? 6. 2 times a half is 1. 2 times 10, 20, right? Now subtract 1. Yeah, subtract 1 across this thing. That gives us minus 21 less than 6x less than 19. And then divide by 6. So that tells me my solution set is 21 over 6 simplifies to like 7/2. Yeah. So minus 7/2. The 3's cancel, right? And then 19's prime, so nothing to do about that. So less than absolute value is nicer. Like the greater than, you have to break up into these 2 cases and union the thing, but the less than is nicer.
Do you also write that in interval notation?
This is interval notation.
Sorry.
That's okay, but right here. That's the interval notation. One more for today. One more. I don't think I've done this one for you guys yet. If I have, my apologies. I'd ask you if I've done it before, but you're going to tell me that I have, so you can leave, so I can't really ask you that. But here it is, 5x squared plus 17x, all right, less than or equal to 12. How do you solve this one? Yeah, we want to make it with a 0 on one side, right? So we subtract 12 to the other side. That's our opening move here. And yeah, we could complete the square, but that would be painful here because it would involve dividing by 5, and then I would face like 17/5, and then I would have it would be, if we can avoid completing the square here, it's in our best interest. And this is a problem from the book, so it means it can factor. So,
Problems that we can't factor.
of course. Let's see here. So 12 is what? 12 is 1 times 12. It's 2 times 6. It's 3 times, 4 times 3 times 4, 4 times 3. The question is, how can you get a 17 from all that, right?
Well, there's a 5x there, so.
So we're doing 5 times something, right? Plus 1 times the other thing, right? How do you get? What's that?
1 and 12.
1 and 12?
Because 1 times 5 is 5.
Like this? No, the 12 over here and the 1 over there? Oh, hey, that's nice. That is almost right.
It's negative 12.
5x plus 3.
Good idea. Oh, I heard so that the reason, let's just pause here for a second. The reason this fails is because what? We need 12, we need minus 12, right? So you have to have plus minus, like, unfortunately. I mean, you're right, that does give me the 17. Great, but I heard a 3 and a 4. Let me try that. 3 and 4. One of them's got to be plus, one of them's got to be minus. Which one do you want, plus or minus?
3.
Is the minus? Then what happens? We get minus 3x, right? Plus 20. Oh, we got a 17, right? And we got the minus 12. We get it all. What are the critical? So we got it. Now what are the critical numbers? Critical numbers. I heard negative 4 and what? 3 over 5. Very good. Now we draw our number line. Which comes first? I think the minus 4, right? How many problems have had minus 4 in today? Like we keep running into problems with minus 4. And then what? Plug in 0. Okay. I want some variety in my life. You're always making me plug in 0. It's so boring. But anyway, that's a good choice because that gives us minus 12, which is negative. Then the sign flip theorem says I change to pluses on the outsides here as we go across the critical number. What is the solution? The negatives, right? Because we're solving less than or equal to 0. So we do minus 4 to 3/5. And I included the answers, the endpoints. Why did I include them? Because we're solving equals to 0. There's no division by 0, no funny business. So that's it. So for the quiz next Wednesday, it is comprehensive. It will cover the material we're covering next week too. So you should scan through the homework for next week before the quiz for best results for yourself. What's that? You can do as many as you want as you have time. But my point to you is the quiz will be covering all of the material we cover in lecture next week, which will be Monday and Friday. And I realize that's slightly unfair.